Myself, KrishnaPrasad, Department of Mechanical Engineering, MIT Mysore. So, and today we are continuing with the next concept. It is called steam and its properties. And the contents regarding to the today's class, it is called steam formation at constant pressure, temperature enthalpy diagram, types of steam, properties of steam. In the properties of steam, we need to study what is meant by the dryness fraction, then specific volume, enthalpy and internal energy. So, the first topic it is called what will be the formation of steam at a constant pressure and how to achieve it. And before going to the what exactly the steam formation, first we need to understand what is meant by the steam. So we all know that all the substances under suitable conditions of temperature, it exists in three states of matter, that is solid, liquid and gas. But water is one of the pure substance that exists in all the three phases. That means it exists as a ice in the solid phase, and it exists as a water in the liquid phase, and it exists as a steam in the gaseous phase. Then what is meant by this steam? When ice melts, it starts transform from solid phase to the liquid phase. Similarly, when water is heated beyond the boiling point, it starts transform from liquid phase to the gaseous phase to become the water vapor. Hence, the steam, it is nothing but it is a water vapor. Then what are the different properties of the steam? The different properties of the steam, it is called dryness fraction, temperature, pressure, enthalpy, specific volume, entropy. So to know the various properties of the steam at the constant pressure, first we need to conduct the experiment how to make the steam initially from the ice. So in the experimental consideration, in this figure it is completely explained about how steam is formed initially from the solid ice at 0 degree centigrade to the superheated steam, and later we are explaining with temperature enthalpy diagram. That means this figure A explaining about how the steams are formed initially from 0 degree centigrade, and this figure it is explaining about what will be the conditions of the temperature and enthalpy whenever it is changing from ice into the superheated steam. So initially let V be the volume occupied by the water at 0 degree centigrade, and it is taken inside the cylinder, and the freely moving piston is placed over the ice, and weight capital W is placed over the piston in order to achieve the constant pressure. So, and the condition of water at 0 degree centigrade, it is represented by point A on the TH diagram. So next, when water is heated, its temperature is slowly rises. Yes, when water is heated, the temperature is slowly rises until water starts boil. Then what will be the temperature when water starts boil? That is called as the saturation temperature. Then what is the definition of saturation temperature? The definition of saturation temperature, it is nothing but the temperature at which water starts boil, it is called as the saturation temperature, and it is denoted by Ts. And the temperature slowly rising from 0 degree centigrade to the saturation temperature, it is represented by line AB on TH diagram. And during this process, there is a slight increase in volume, and this is represented by figure B, and the volume it is called Vf. So this is regarding to the transformation from solid phase to the liquid phase. Then further addition of heat, what happens? So further addition of heat, it initiates the evaporation of water. So during the evaporation of water, so the temperature is remains at the saturation temperature. So we can also observe in the temperature enthalpy diagram. So during the evaporation process, so the temperature is remains at the saturation temperature, and this evaporation will be continuous until all the water particles are get converted into dry steam. So then what is this? The figure C. So this is the condition called wet steam. That means during this condition, which contains both water as well as the water vapor. Okay, so the wet steam, it is nothing but which contains both water as well as the water vapor, but the condition of the temperature, it is remains at the saturation temperature, and this is shown in the figure C, that is called, and the volume occupies Vfg. And I already told, and the evaporation of water is continuous until all the water particles are get converted into the dry steam. So the condition of the dry steam, it is represented by point C on the TH diagram. Okay, so condition of the dry steam is represented by point C on the TH diagram, and during this condition again the temperature is remains at the saturation temperature, and during this condition the volume occupies, that is called Vg. That means during this condition all the water particles are get converted into the water vapor, and this occupies the volume called as Vg. Then last one, further addition of heat. That means if the dry steam is heated further, the both temperature and volume of the steam is going to increases. Then what is the process? The process of heating the dry steam above the saturated temperature, it is called as the process of superheating, and that is called as the HSUP. So I will tell you the later what exactly the enthalpy is regarding to the latent heat and latent heat of evaporation and the latent heat of superheated condition. So when dry steam is heated above the saturation temperature, both temperature and the volume is going to increases. The increase in temperature, it is represented by TSUP, and increase in volume, it is represented by HSUP. So this is regarding to the superheated steam. So the condition of steam at the superheated temperature, it is called as the superheated steam. So now let us be coming to the temperature enthalpy diagram. In the temperature enthalpy diagram, I already told the temperature of water at 0 degree centigrade, it is represented by A, and the temperature of water at saturation temperature, it is denoted by Ts, and the temperature of steam at the superheated condition, it is represented by TSUP. Then what is meaning of HF, HFG and HSUP? That means first, sensible heat, or it is nothing but latent heat. So what is meant by the sensible heat? Here amount of heat required to rise the temperature of water from 0 degree centigrade to the temperature of water at saturation temperature, it is called as the latent heat or sensible heat. I repeat, what is meant by the sensible heat or a latent heat? It is nothing but the amount of heat required to rise the temperature of water from 0 degree centigrade to the saturation temperature at constant pressure. It is called as the sensible heat or latent heat. So, and this is represented by HF. Next, I already told, so further addition of heat, the transformation starts from liquid phase to the gaseous phase through evaporation process. Then what is meant by the latent heat of evaporation? The latent heat of evaporation, it is represented by HFG. So latent heat of evaporation, it is nothing but your amount of heat required to rise the temperature of water from 0 degree centigrade to the temperature of water at saturation temperature, it is called as the latent heat of evaporation. That means your amount of heat required to convert 1 kg of water at 0 degree centigrade to the 1 kg of dry steam at the saturation temperature at a constant pressure, it is called as the latent heat of evaporation. Similarly, what is meant by the HSUP? So HSUP, it is nothing but amount of superheat. Here amount of heat required to rise the amount of heat required to convert 1 kg of water at 0 degree centigrade to the 1 kg of superheated steam at the superheated temperature, it is called as the amount of superheat or degree of superheat. And the degree of superheat, it is measured by the difference between the temperature of TSUP minus Ts. This is called as the degree of superheat. So again, I will telling about how the steams are formed initially from ice. So just observe in the figure A, initially water is at 0 degree condition and the volume occupies is Vf. So if you are heating the water, then its temperature is slowly rises until water starts boil, and during this condition it occupies the volume of Vf. So further addition of it initiates the evaporation of water. So evaporation of water is continuous until all the water particles are get converted into dry steam. So dry steam, it is represented by volume Vg. So before it get converting into the dry steam, first it get converted into the wet steam, and the condition of the wet steam, it occupies the volume of Vfg. So further, if the dry steam is heated above the saturation temperature, then it converted into the superheated steam. The superheated steam occupies the volume of VSUP, and the temperature at the ice, it is called 0 degree centigrade, and at the wet steam and the dry steam, it is the saturation temperature, and at the superheated temperature, it is called superheated temperature. So next, last one. So this is called sensible heat, latent heat of evaporation, and the latent heat of superheat or amount of superheat. So here sensible heat, it is represented by HF, and the latent heat of evaporation, it is represented by HFG, and the amount of superheat, it is represented by HSUP. So this is regarding to the formation of steam initially from ice into the superheated steam from 0 degree centigrade to the temperature of superheated. The next topic it is called the different states of steam. We already learned what is meant by the steam and how steams are made initially from water at 0 degree centigrade to the superheated steam at a temperature of TSUP. So in the three different states of steam, the first one it is called wet steam. The wet steam, it is nothing but it is a two-phase mixture which containing both water as well as the water vapor in thermal equilibrium at the saturation temperature corresponding to the given pressure, that is called it as the wet steam. Then what is meant by the dry steam? So dry steam means it is the steam which is completely in a pure vapor form and do not contain any water particle in its suspension. That is called as the dry steam. And what is the temperature regarding to the dry steam? The temperature regarding to the dry steam, it is again the saturation temperature and at a given pressure. So the dry steam, it is defined as a steam which is present completely in a pure vapor form and do not contain any water particle in its suspension at the saturation temperature corresponding to the given pressure, that is called as the dry steam. The next one it is called superheated steam. What is meant by the superheated steam? If the dry steam is heated beyond the saturation temperature and then superheated steam is produced, then superheated steam produced at a temperature, it is called as the superheated temperature, and at a given corresponding pressure it is called as the superheated steam. The next it is called as the different properties of the steam. So under the different properties of the steam, first we need to know what is meant by the dryness fraction. So dryness fraction, it is defined as the ratio of mass of actual dry steam present in a sample quantity of wet steam to the total mass of wet steam, it is called as the dryness fraction. So just observe, so this is the wet steam, that means which containing both water as well as the water vapor in its suspension, that means which contains the mass of both MF and Mg. If you are taking only the sample quantity of wet steam, then you separate both water as well as the water vapor. Then the mass of water vapor present in a sample quantity of wet steam, it is called Mg, and the mass of water particle present in a sample quantity of wet steam, it is called MF. Then dryness fraction, it is nothing but MF divided by MF plus Mg. So that means here the mass of sample quantity of water particle present in a sample quantity of wet steam to the total mass of wet steam, it is called as the dryness fraction. Okay, so dryness fraction having the no unit, because here mass for the wet steam and the total mass of wet steam, it is both in terms of the kg, it will going to cancel out, and the dryness fraction we are measuring in terms of below 1. If the dryness fraction is 1, then it is nothing but the dry steam. Next property it is called specific volume. Then what is meant by the specific volume? Here the specific volume, it is defined as the volume occupied by the known mass of a substance, that is called as the specific volume. So first under that, what is meant by the specific volume of the dry steam? Here the specific volume of the dry steam, it is defined as volume occupied by 1 kg of dry steam at the saturation temperature and a corresponding given pressure, that is called as the specific volume of the dry steam. And the specific volume of the dry steam, it is represented by the unit, it is called Vg, and it is expressed in meter cube per kg. Next, what is meant by specific volume of the wet steam? The specific volume of the wet steam, it is defined as volume occupied by 1 kg of wet steam. That means the wet steam which contains both water as well as the water vapor at a given dryness fraction and at a given corresponding pressure, then it is called as the specific volume of the wet steam. The specific volume of the wet steam, it is denoted by Vw, and that will be is equal to X into Vg. So what is meant by the X? X is nothing but the dryness fraction, and Vg it is called specific volume of the dry steam. So this is regarding to the specific volume of the wet steam. The next one, it is called specific volume of the superheated steam. The specific volume of the superheated steam, it is defined as the volume occupied by 1 kg of superheated steam at the superheated temperature and at a given corresponding pressure, it is called as the specific volume of the superheated steam. So, and according to the Charles law, we know that Vg by Ts is equal to Vsup by TSUP. So in order to know the specific volume of the superheated steam, the formula it will become Vg into Ts into TSUP, and it is expressed in meter cube per kg. Next, what is meant by the then enthalpy? So enthalpy, it is nothing but it is the product of U plus PV. Okay, so first thing we need to measure what is meant by the enthalpy of the wet steam. So enthalpy of the wet steam, it is nothing but here amount of heat required to convert 1 kg of water at 0 degree centigrade into the 1 kg of wet steam at a given dryness fraction and at a given pressure, that is called it as the enthalpy of the wet steam. And the enthalpy of the wet steam, it is denoted by HW, and the HW is equal to HF plus X into HFG. So here what is X represent? X represents the dryness fraction, and HFG represents the latent heat of evaporation, and HF represents the sensible heat. So the enthalpy of the wet steam is equal to HF plus X into HFG, and unit is in kilojoule per kg. So next, what is mean by the enthalpy of the dry steam? So enthalpy of the dry steam means your amount of heat required to convert 1 kg of water at 0 degree centigrade into the 1 kg of dry steam at a given constant pressure, then it is called enthalpy of the dry steam. And the enthalpy of the dry steam, it is given by the formula G is equal to HF plus HFG. So HF represents the sensible heat or a latent heat, and HFG represents the latent heat of evaporation. The next last one, it is called enthalpy of the superheated steam. So enthalpy of the superheated steam, it is nothing but the amount of heat required to convert the 1 kg of water at 0 degree centigrade into the 1 kg of superheated steam at the superheated condition at at a given pressure. It is called it as the enthalpy of superheated steam. And the enthalpy of superheated steam, it is denoted by HSUP, and this is equal to Hg plus CPS, that is nothing but is the specific heat of superheated condition, and TSUP minus TS. So TSUP minus TS is nothing but it is the amount of superheat or degree of superheat. So this is regarding to the enthalpy. Next, last one, it is called internal energy. What is meant by the internal energy? Here every substance has definite amount of energy stored in it, that is called it as the internal energy. And this internal energy, and it is usually denoted by U is equal to H minus PV. Okay, so that means what is the amount of heat energy stored in the particular steam, that is called it as the internal energy of the steam. For the internal energy of the dry steam, it is denoted by Ug, and that will be is equal to Hg minus P into Vg. Similarly, for the wet steam, UW is equal to HF plus X into HFG minus P into X into Vg. Here X represents the dryness fraction, and the remaining it is called enthalpy of sensible heat, enthalpy of latent heat of evaporation, and P is the pressure, and Vg is the specific volume of the dry steam. And the next one, it is called superheated steam. So internal energy of the superheated steam, it is represented by U superheated, that will be is equal to HSUP minus P into V into VSUP. So this is regarding to the internal energy. So this will complete the properties of steam. So, and this class we are completed with what is the steam formation, and then temperature enthalpy diagram. Later the three different types of steam, that is called wet steam, dry steam, and superheated steam. Then the different properties of the steams like dryness fraction, then specific volume, enthalpy, and internal energy. Hello everyone. So the next topic in this steam formation and its properties, it is called it as the numericals. So in the before moving on to the numericals, first again we need to understand some of the basic definitions of the steam formation and its properties. So first one, it is called as the dryness fraction. So dryness fraction, it is defined as the ratio of amount of dry steam present in a sample quantity of wet steam to the total amount of wet steam. So this is regarding to the dryness fraction. Next, it is called the enthalpy of the wet steam, and it is denoted by HW, and the HW is equal to HF plus X into HFG. So what is mean by the HF? The HF, it is nothing but latent heat or a sensible heat. So latent heat means here amount of heat required to rise the temperature of water from 0 degree centigrade to the saturation temperature at a given constant pressure. It is called it as the sensible heat or a latent heat. And the next one, it is called enthalpy of the dry steam. Here the amount of heat required to convert the 1 kg of water at 0 degree centigrade to 1 kg of dry steam at the saturation temperature at a given constant pressure, it is called it as the enthalpy of the dry steam. And the enthalpy of the dry steam, it is denoted by Hg, and the Hg is equal to HF plus HFG. So HFG means is nothing but the latent heat of evaporation. Similarly, last one, it is called as the enthalpy of superheated steam. It is nothing but here amount of heat required to convert the 1 kg of water at 0 degree centigrade to 1 kg of superheated steam at the superheated temperature at a given constant pressure. It is called enthalpy of superheated steam. And the enthalpy of superheated steam, the formula it is equal to HSUP is equal to Hg plus Ms, means the mass of steam, and the specific heat of steam is equal to Cps, and then TSUP minus Ts. TSUP is nothing but superheated temperature, and the Ts is called as the saturation temperature. So next we are moving on to the very first problem regarding to the steam formation. It is called here the determine the dryness fraction of a steam of 1 kg of water is in suspension with 39 kg of dry steam. So here they need to find out what is the dryness fraction. So the dryness fraction formula X is equal to mg plus mf plus mg. We know that according to the data, so mg is called as the dry steam and mf is called as the mass of water in its suspension. Therefore, substitute the mg is equal to 39 kg and mf is equal to 1 kg. Then again mg is equal to 39 kg. Therefore, x is equal to 39 kg divided by 40 kg. So that the dryness fraction we obtained, it is nothing but 0.975. That means this indicates there is a 97% of steam, it is at dry condition, and remaining 2.5% of steam it is in the wet condition. Therefore, here the condition of the steam, it is nothing but it is the wet steam. This indicates the 97.5% of dry steam indicates it is remaining 2.5% of steam, it is still under the water condition. Therefore, the condition of steam, it is called as the dry steam. The second numerical, it is called find the enthalpy of 1 kg of steam at 12 bar when steam is dry saturated. That means we need to find out the Hg, and then steam is 22% wet. That means here they are mentioning it is 22% wet, then the steam becomes wet steam. Then we need to find out the Hw, and then steam is at superheated condition and the superheated temperature it is at 250 degrees centigrade. And using the steam table, assume specific heat of steam is equal to 2.25 kilojoule per kg degree Kelvin. So just now I am writing the data here. Mass of steam is equal to 1 kg and superheated temperature is equal to 250 degrees centigrade, and specific heat of steam is equal to 2.25 kilojoule per kg degree Kelvin. But in this form of problem, they are mentioned at its, so by using this steam table, so thermodynamics data handbook by B.T. Nijaguna and B.S. Samaga. So I am considering from the page number 12 and the pressure of 12 bar, I am writing the values of saturation temperature is equal to 188 degrees centigrade and HF is equal to 798.4 kilojoule per kg and HFG is equal to 1984.3 kilojoule per kg and Hg is equal to 2782.7 kilojoule per kg. So initially for the first condition they are asking about what is the enthalpy of steam at dry saturated condition, that means Hg. We know that Hg is equal to Hf plus Hfg. Here from the data handbook we know that the value of Hf is equal to 798.4 plus Hfg is equal to 1984.3. So summation of these two values is equal to 2782.7 kilojoule per kg. So instead of doing the summation of Hf plus Hfg, we can take the directly the enthalpy of dry saturated steam Hg is equal to 2782 kilojoule per kg. So next, second value. That means here steam is 22% wet. That means for the enthalpy of the wet steam, formula is equal to Hf plus x into Hfg. But here what is mean by the x? X is nothing but dryness fraction. If the steam is dry steam, then dryness fraction is equal to 1. But here they mention steam is 22% wet, then dryness fraction is equal to 1 minus 22%. That means 1 minus 22 by 100 is equal to x is equal to 0.78. So now substitute the value of x is equal to 0.78 in this equation. Therefore, enthalpy of wet steam is equal to HF is equal to 798.4, x is equal to 0.78 and HFG is equal to 1984.3. By simplifying this equation, we get the value of 234615 kilojoule per kg. So this is the enthalpy of the wet steam at steam is 22% wet or 0.78 dryness fraction or 78% of dry steam. So next, third one, it is called superheated steam. So that means HSUP is equal to formula Hg plus Ms, that means mass of steam, CPS into TSUP minus TS. Here HSUP is equal to, what is the value of Hg? That is 2782.7 plus mass of steam is equal to 1 kg, CPS is equal to 2.25 minus 250 into 188. After simplifying this, the enthalpy of superheated steam is equal to 2922.2 kilojoule per kg. So this is the values for enthalpy of the dry steam Hg is equal to 2782.7 kilojoule per kg. That means at this point the enthalpy of dry steam is equal to 2782.7 kilojoule per kg, and enthalpy of wet steam, that is 22% wet, that means it is 78% dry. At this condition HW is equal to 2346.15 kilojoule per kg. So similarly, at the enthalpy of superheated steam, that means at this condition enthalpy of the superheated steam is equal to 2922.22 kilojoule per kg. So this is regarding the enthalpy of the steam at three different conditions, that is called for dry saturated state and 22% wet state and superheated state. The next problem in the steam formation and its properties, it is called, here the steam is at 8 bar pressure and the dryness fraction is equal to 0.95. Determine entropy and enthalpy of the steam. So we know that again in this problem they have mentioned the what is the pressure of the steam, it is at 8 bar pressure. So again the same, using the same data handbook, we need to take on the values of HF, HFG, HG, SF, SFG and SG for 8 bar pressure. So for 8 bar pressure, HF is equal to 721, HFG 2046.5 and HG 2767.5. Then SF 2.045, 4.6139 and 6.6596. But we need to analyze what is the condition of the steam. I already told what is meant by the dryness fraction. The dryness fraction of the steam, it is nothing but here the mass of dry steam present in a known quantity of wet steam to the total mass of wet steam. That means if it is having the dryness fraction of 0.95, then it is nothing but here it is only 95% of dry steam is happened in case of the steam formation, but still having the 5% of steam, it is at the wet condition. Therefore here the condition of the steam, it is nothing but the wet steam. So what is the formula for enthalpy of wet steam? That will be is equal to HF plus X into HFG. Here HW is equal to HF is equal to 721 plus X is equal to 0.95 and HFG is equal to 2046.5. So after simplification, HW is equal to 2665.45 kilojoule per kg. Similarly, for the entropy of wet steam for having the 0.95 dryness fraction, so the formula is equal to SW is equal to SF plus X into SFG. So what is the value of SW? So here SF is equal to 2.045 plus X is equal to 0.95 plus SFG is equal to 4.6139. So again, after the simplification, so the entropy of wet steam is equal to 6.4293 kilojoule per kg degree Kelvin. So this is for entropy of the wet steam of having the 0.95 dryness fraction, and 2665.45 is the enthalpy of the wet steam of having the 0.95 dryness fraction. So this is regarding to the numerical 3. Okay, the next problem regarding to the steam formation and properties, it is called here they determine the amount of heat required to produce the 1 kg of steam at a 6 bar pressure. Here again 3 conditions are given. First one, it is called steam is wet having the dryness fraction of 0.9, and next after that it is called steam is dry saturated, and steam is superheated at 256 degree centigrade. So here first condition, it is called steam is wet, that means HW is equal to HF plus X into HFG. That means here HF value is given, that is 670.4. So and the dryness fraction is 0.9 and HFG is 2085. So after the simplification, and HW is equal to 2546.99 kilojoule per kg. So in the second condition, we need to find out the amount of heat required at dry saturated state. I already told, so the formula for dry saturated state is Hg is equal to Hf plus Hfg. So Hf is equal to 670.4 plus Hfg is equal to 2085. So addition of these two, it is nothing but Hg is equal to directly 2755 kilojoule per kg. So this is similar to the value of Hg what we have taken from the data handbook. And the last one, the enthalpy of superheated steam. So for the enthalpy of superheated steam, formula is equal to Hg plus mass of steam into specific heat into TSUP minus Ts. So substitute the values. So Hg is equal to 2755, mass of steam 1 kg, and specific heat 2.3, and TSUP 256, and the Ts 159. So after the simplification, HSUP is equal to 2979.06 kilojoule per kg. So that means here the value of HW indicates the enthalpy of wet steam of 25460.99 kilojoule per kg, and this is 0.95 dryness fraction. So that means 0.95 dryness fraction means it is 95% dry and only 5% wet. So at this condition, so enthalpy required is 2546.99 kilojoule per kg.